Hello everyone. In this class we will see important proof of trigonometric function by using the identities. How to prove LHS is equal to RHS. So let's solve one by one. To prove that questions we required some formulas. For example, tan theta is equal to sine upon cos and cot theta is nothing but cos theta upon sin theta. And the most important thing is identities. We know that sin square theta plus cos square theta is equal to 1 plus tan square is equal to sec square theta, 1 plus cot square is equal to cos x square. Similarly, we can write down each identity in a three different way. For example, cos square is nothing but 1 minus sin square and so on. And some important formulas: a square minus b square, which is a plus b, a minus b, and a cube plus b cube, and what is a cube minus b cube. So this, by using these formulas and algebraic identities, we have to solve the proofs. So let's solve the first important one, that is rationalization. And this is a classic problem. We have to prove that root of 1 plus sine upon 1 minus sine is equal to sec theta plus tan theta. So remember the trick: whenever this root sign will come, okay, and the terms are like, for example, in the numerator and denominator terms are similar, only plus and minus difference is there. So in that case, the first step is always multiply and divide by the denominator by changing the middle sign. So in the denominator we have 1 minus sin theta, so we'll multiply 1 plus sin theta upon 1 plus sin theta inside the root. So in the numerator, 1 plus sin theta multiplied by 1 plus sin theta, which is nothing but 1 plus sin theta the whole square. In the denominator we apply the identity a minus b, a plus b. Okay, so a minus b, a plus b is nothing but a square minus b square, a square minus b square. So here instead of a we have 1, instead of b we have sin theta. So 1 square is 1 minus sin square theta is sin square theta. Okay, so after that numerator we have taken as it is, but in the denominator 1 minus sin square theta, which is nothing but cos square theta from the first identity. So now numerator and denominator both the term in a square form, so we can write down as inside the square root 1 plus sin theta upon cos theta the whole square, because both the quantity are in a square form, so we can write down the whole square. Okay, so now we can cancel out the square and root. So what will remain? 1 plus sin theta in the numerator and the denominator cos theta. So if we split the denominator, 1 upon cos theta plus sin theta upon cos theta. So 1 upon cos theta is sec theta plus sin theta upon cos theta is tan theta, and that actually we wanted. So LHS is equal to RHS. Look at the next proof. The next is reciprocal conversion. So suppose like this is given, you have to prove cosec theta minus cot theta the whole square is equal to 1 minus cos upon 1 plus cos. So in that case we will convert this cosec and cot in terms of sine and cos. Okay, so most probably in the proof always convert cosec, cot, tan in terms of sine and cos. So cosec means nothing but 1 upon sin theta, cot means nothing but cos theta upon sin theta, and the whole square as it is. Now denominator is same, so we'll just add the numerator. So 1 minus cos theta whole divided by sin theta and the whole square. So if we split the square of the numerator, so 1 minus cos theta the whole square, and if we take the square in the denominator, then it becomes sin square theta. Now if we apply the identity, sin square theta is nothing but 1 minus cos square theta, because we want the answer in terms of cos only, so we have to remove this sign. Okay, so how to change sign in terms of cos? Sin square is nothing but 1 minus cos square theta, so that we applied in the denominator. So 1 minus cos square theta. Now 1 means we can write down as 1 square. So if we apply a square minus b square identity in the denominator, so it will become a minus b, a plus b. Okay, in the numerator 1 minus cos theta the whole square. So x square, how to write x square? X square can be written as x multiplied by x. Similarly 1 minus cos theta the whole square, that we can write down as 1 minus cos theta into 1 minus cos theta. Okay, and the denominator we have applied a square minus b square, that is a minus b, a plus b. So you can see that 1 minus cos theta is common, so that will get cancelled. So what will remain? 1 minus cos upon 1 plus cos, that we wanted. So LHS is equal to RHS. Proof is done. Look at the next proof, the cross multiplication. So whenever you will come across the LHS like this, cos upon 1 plus sine. After that, in the numerator, 1 plus sine upon cos. So what is the first thing in your mind will come? The cross multiplication, correct? So we'll do the cross multiplication in the first step. So cos theta into cos theta, which is cos square theta. 1 plus sine into 1 plus sine, which is 1 plus sine theta the whole square here. Okay. In the denominator, cos theta multiplied by 1 plus sine theta. Now next step, this cos square theta as it is, we will open this bracket 1 plus sine theta the whole square. So we'll apply here a plus b the whole square form. We have to expand. So what is the form? A square plus 2ab plus b square. So a is here 1, so 1 square is 1. Then 2 times 1 into sin theta. So 2 into sin theta into 1, which is 2 sin theta, plus b is here sin theta, so sin theta square. Denominator as it is. Now if we look at here, first term is cos square theta and the last term is sin square theta. So we know the identity sin square theta plus cos square theta, which is nothing but 1. Okay, so if we combine them, sin square plus cos square, which is 1. After that, one more 1 is there, that is as it is, plus 2 sin theta. Denominator as it is. Now if we add 1 plus 1, 1 plus 1, which is nothing but 2, and the second term is plus 2 sin theta upon denominator as it is. Okay. So in the numerator you can say that 2 is common. So if we take 2 common, so inside the first term 1 will remain, in the second term sin theta will remain. Denominator still as it is. Now you can see that 1 plus sin theta, 1 plus sin theta will get cancelled. So what will remain? 2 upon cos theta. Okay, so 2 as it is, and 1 upon cos theta is nothing but sec theta, and that what we wanted. So our proof is done. The next proof, the cubic switch. Okay, so the LHS is now given in the cubic form. In the numerator, sin cube theta plus cos cube theta. So whenever like this will come, we have to apply this identity, a cube plus b cube. So a cube plus b cube can be written as a plus b into a square minus ab plus b square. Okay, so in this case our a is sin theta and b is nothing but cos theta. So if you apply that identity, so a plus b means sin theta plus cos theta. After that, a square minus ab plus b square. A square means sin square theta minus a into b means sin theta into cos theta plus b square means cos square theta. Denominator as it is, and plus sin theta into cos theta is also as it is. After that, if we cancel out this sin theta plus cos theta, so what will remain? In the numerator, sin square theta minus sin theta cos theta plus cos square theta, and last term sin theta plus cos theta. Okay, so if we just open this bracket, this plus sin theta cos theta minus sin theta cos theta, that will get cancelled. So what will remain? Sin square theta and plus cos square theta. We know that sin square theta plus cos square theta is nothing but 1. So our proof is done here. So by using this a cube plus b cube identity and by using this sin square theta plus cos square theta is equal to 1, we have solved this proof. Look at the next part. The double square triad. Okay, this is also the important proof. What is given in the LHS? Sin theta plus cosec square theta, cosec theta the whole square plus cos theta plus sec theta the whole square. So whenever whole square is there, just open it. We'll apply a plus b the whole square here as well as a plus b the whole square here. So we know that a plus b is the whole square is nothing but a square. Then so a is sin theta here, so sin square theta plus b square, that is cos square theta, plus 2ab, that is 2 into sin theta cos theta. Okay, a square plus b square plus 2ab, that means sin theta into cos theta, plus here also a square, which is cos square theta, b square, which is sec square theta, plus 2 into ab. So 2a is cos theta, b is sec theta. Now we'll just combine the like terms. So sin square theta as it is plus cosec square theta as it is. Now look at the third term, 2 times sin theta into cos theta. Okay, so we know that sin and cosec are reciprocal of each other. Okay, so sin theta, so cosec theta is nothing but 1 upon sin theta, correct? So this sin theta will get cancelled, so answer is 1. So whenever reciprocal some function with reciprocal multiplication is there, the answer is always 1. So sin theta into cosec theta, answer is 1. Similarly, cos and sec, they are reciprocal of each other, so answer is 1. So here 2 into sin theta cosec theta, so 2 as it is, but sin into cosec is 1, so 2 into 1 is 2. After that, this cos square theta as it is, sec square theta as it is. After that, 2 as it is, and then cos theta into sec theta, which is nothing but 1. So 2 into 1 is 2. Okay, so if we add up this 2 and here one more 2 is there, so 2 plus 2, which is nothing but 4. And if we combine the like terms, sin square theta is here and 1 plus cos square theta is here, so that we will return together, and remaining thing cos x square theta and sec square theta, that we have written here. So we know that sin square theta plus cos square theta, which is 1. After that 4 as it is. After that we'll apply the identity here because we want answer in the tan square and cot square theta terms. So cos x square theta is nothing but 1 plus cot square theta, identity. Okay, this identity we are applying. Sec square theta is nothing but 1 plus tan square theta. So now if we combine the numbers 1 plus 4 plus 1 plus 1, which is nothing but 7, and the remaining term cot square theta and tan square theta as it is. So that is nothing but is equal to over RHS, right hand side. Look at the next proof. The power of 6 identity. So in this proof we'll apply power of 6 in terms of power of 2 and 3. So sin raised to 6 theta plus cos raised to 6 theta is equal to, we have to prove this thing. So proof is very simple. 6, how to write 6? If we break 6 in terms of 2 and 3, then we can write down sin square theta whole raised to power 3. Okay, so if you multiply, you will get again 6. Similarly, cos raised to 6 theta, that we can write down as cos square theta raised to power 3. Correct? So now we will apply a cube plus b cube identity. So what is a cube plus b cube? A plus b the whole cube minus 3ab into a plus b. So a is here sin square theta and b is here cos square theta. So if we apply this formula, so first term is what? A plus b the whole cube. That means sin square theta plus cos square theta the whole cube. Then minus 3 times a into b. So a is sin square theta, b is cos square theta. Inside the bracket a plus b. So a is sin square theta plus b is cos square theta. Okay. We have just applied this identity, a cube plus b cube, nothing else. So a is here sin square theta and b is here cos square theta. So we know that sin square theta plus cos square theta, which is 1. So 1 as it is, whole raised to power 3 as it is, minus this sin square theta into cos square theta as it is. Here also sin square plus cos square theta is 1. So 1 cube is 1 minus 3 sin square theta cos square theta into 1, which is nothing but same thing. And that what exactly we wanted. Okay, so RHS is equal to LHS. Look at the next proof. The fraction split. So in the LHS is it given tan theta upon 1 minus cot plus cot upon 1 minus tan. We wanted answer in terms of sec and cosec. Okay, so we'll convert here this cot theta in terms of tan theta everywhere. So here cot is there, we'll write 1 upon tan theta. Here also cot is there, we'll write 1 upon tan theta. Then here if we do the cross multiplication in the denominator, so tan theta into 1 tan theta minus 1. So we'll get tan theta minus 1 whole divided by tan theta. Okay, and the numerator tan theta is as it is. So we know that denominator of the denominator will go in the numerator. So this tan theta into tan theta, it become tan square theta, and the denominator is tan theta minus 1 as it is. And in the second term 1 upon tan theta is there in the numerator. So denominator of the numerator, that will go in the denominator. Okay, so 1 as it is, and this tan theta will come in the denominator. So tan theta multiplied by tan theta minus 1. Now look at the denominator of both the term. Here it is tan theta minus 1, here it is tan theta minus 1 into tan theta. So one extra tan theta is there here. Okay, so we have to make denominator identical. That means we have to make the same denominator to solve easily. So in the first step, 1 tan theta is not there here. So we'll multiply and divide 1 tan theta extra. So in the denominator we have multiplied tan theta, in the numerator also we'll multiply 1 tan theta. Okay, so in the numerator it become tan theta into tan square theta, which is tan cube theta, and the denominator will be tan theta multiplied by tan theta minus 1. So this is the first term after multiplying tan theta in the numerator and denominator. So you can see that now the denominator is same. So denominator, after that we can write down common tan theta into tan theta minus 1, In the numerator, we have to just simplify. The first term is tan cube theta, and the second term is minus 1. Okay. Now, after that, this tan cube theta as it is minus 1. How to write 1? 1 can be written as 1 cube. Okay, and denominator same thing as it is. So you can see that in the numerator is nothing but a cube minus b cube. So we'll apply the identity a cube minus b cube, that is same as a minus b into a square plus a plus b, a square plus ab plus b square. Okay, the identity is a cube minus b cube is equal to a minus b into a square plus ab plus b square. So in this case, a is nothing but tan theta and b is nothing but 1. So we have to apply in this identity, instead of a we have to put tan theta, instead of b we have to put 1. So tan theta minus 1 inside the bracket tan square theta plus a into b, that is tan theta into 1, which is tan theta, plus b square, that is 1 square, which is 1. Okay. Denominator as it is. So now we can see that in the numerator tan theta minus 1, tan theta minus 1 will get cancelled. So what will remain? Tan square theta plus 1 in the numerator, in the denominator tan theta. So we'll split the denominator, tan square theta upon tan theta, which is nothing but tan theta. One tan theta will get cancelled. After that, tan theta upon tan theta, which is 1. After that, 1 upon tan theta, which is cot theta. Okay, so we are getting tan theta plus 1 plus cot theta. But we want answer in terms of sec and cosec. So we have to break this tan and cot in terms of sine and cos. Okay, so this 1 that we will write in the starting. After that, plus tan theta means sin theta upon cos theta, plus cot theta means cos theta upon sin theta. So if we do the cross multiplication, this 1 as it is, okay. Now we'll do the cross multiplication. So sin theta into sin theta, sin square theta, plus cos theta into cos theta, cos square theta, divided by cos theta into sin theta. So in the numerator, sin theta, sin square theta plus cos square theta, which is 1, upon in the denominator sin theta into cos theta. So this 1 as it is, plus 1 upon sin, which is nothing but cosec theta, and 1 upon cos, which is nothing but sec theta. Okay, so our proof is done. Look at the next one. The LHS is given sin theta minus 2 sin cube theta, in the denominator 2 cos cube minus cos. So the first step you can easily do it, that is take the common, whatever is common. So in the numerator, sin is common. Okay, one sin we can take common. So inside the bracket, what will remain? 1 minus 2 sin square theta. And from the denominator, if we take 2 cos theta common, so inside the bracket 2 cos square theta minus 1 will remain. Okay. So now to make the answer in terms of tan theta, this 1 can be written as sin square theta plus cos square theta, correct? Minus this sin square theta as it is. In the denominator, cos theta as it is, 2 sin cos square theta as it is, and this one again after minus. Okay, after minus we'll write inside the bracket 1 can be written as sin square theta plus cos square theta, because sin square plus cos square is 1. So instead of 1 we have written sin square plus cos square. Now this outside whatever terms are there, sin upon cos, that is as it is. If you see the numerator, this is sin square theta, and here it is minus 2 sin square theta. So sin square minus 2 sin square, which is nothing but minus sin square theta, and this plus cos square theta as it is. So cos square theta minus sin square theta in the numerator, denominator 2 cos square theta, and if you multiply this minus inside, minus plus minus, so 2 cos square minus cos square, which is cos square, and minus sin square theta as it is. So inside the bracket we'll get the same thing, cos square minus sin square upon cos square minus sin square, so that will get cancelled. So what will remain? Sin theta upon cos theta, which is nothing but tan theta. Okay. Look at the next proof. So in the LHS, tan plus sec minus 1 upon tan minus sec plus 1 is given. So we want 1 plus sin upon cos. Okay. So we'll write tan plus sec, the starting two term as it is, and after that this 1, This 1 can be written as sec square theta minus tan square theta by using the identity. Okay, the identity we have 1 plus tan square theta is equal to sec square theta. So if we take this tan square theta that side, we will get 1 is equal to sec square theta minus tan square theta. Correct? So 1 can be written as sec square theta minus tan square theta. Denominator will write as it is. Now, this first type sec theta, we'll write sec theta first and then tan theta later. Okay, because it is plus, minus, here we'll apply a square minus b square identity. So a square minus b square, which is nothing but a minus b into a plus b. So sec square theta minus tan square theta, which is sec theta minus tan theta into sec theta plus tan theta. Okay. So after that you can see that sec theta plus tan theta, and here also sec theta plus tan theta. Okay. This is the first term, and this is full thing is the second term. So from both the term we will take sec theta plus tan theta as common. So if we take sec theta and tan theta common, then inside the bracket, in the first term 1 will remain, then minus, in the second term sec theta minus tan theta will remain. Okay. So if we multiply this minus sign inside, then what will get? The first bracket as it is, sec theta plus tan theta. In the second bracket 1, then if you multiply minus inside, we will get minus sec theta, minus minus plus tan theta. So if you look at the denominator is exactly the same thing. Tan theta minus sec theta plus 1. Okay, 1 is there, minus sec theta is there, and plus tan theta is there. So this denominator and this thing will get cancelled. Okay, so what will remain? Sec theta plus tan theta. So sec means nothing but 1 upon cos, and tan means sine upon cos. So denominator is same, cos theta. So we'll write cos theta in the denominator. Then if we just add numerator 1 plus sin theta, okay, so we got our answer. LHS is equal to RHS. Look at the last one, the product elimination. So we have two bracket. So 1 plus cot minus cosec into 1 plus tan into sec. So we'll convert cot, cosec, tan, sec, everything in terms of sine and cos. So 1 as it is, cot means cos upon sine, cosec means 1 upon sine. Here also 1 as it is, tan means sine upon cos, sec means 1 upon cos. So here, if you can see that sine denominator is common here, same. Here also cos theta is same. Okay. So 1 plus denominator is same in the first bracket sin theta. So we will add the numerator. So cos theta minus 1. Okay. Similarly in the second bracket, 1 plus denominator is same, cos theta. So we will add the numerator. So sin theta plus 1. After that we have to do the cross multiplication. So this sin theta we have to multiply with 1. So we'll get sin theta into 1, that is sin theta, plus cos theta minus 1 upon sin theta. Similarly in the second step, second bracket, we have to multiply this cos theta into 1. So we'll get cos theta plus sin theta plus 1 upon cos theta. Okay, so we have reached this step here. After that, if you see sin theta plus cos theta, if we take this sin theta plus cos theta is a and this one is b, okay, so this you can see that this is nothing but a minus b, and this is a plus b. Okay, a minus b, a plus b. A is nothing but sin plus cos, and b is nothing but 1. So a minus b, a plus b, if you apply, it is nothing but a square minus b square. So a is sin theta plus cos theta the whole square, minus b is a square. Okay, here we have applied like this: sin theta plus cos theta, that is a minus 1 into sin theta plus cos theta plus 1. Okay, so a minus b into a plus b, that is nothing but a square minus b square. Denominator sin theta into cos theta as it is. So if we apply here a plus b the whole square, if we expand this, so a square, which is sin square theta, plus b square, which is cos square theta, plus 2 times ab, so 2 into sin theta cos theta, minus 1 square is 1. Okay, so sin square theta plus cos square theta, which is nothing but 1, plus 2 sin theta cos theta as it is, and this minus 1 as it is. Denominator sin theta cos theta as it is, So this plus 1 minus 1 will get cancelled. So what will remain? 2 sin theta into cos theta upon sin theta cos theta. So this sin theta, cos theta will get cancelled. So answer is 2, which is nothing but LHS is equal to RHS. So these are the tricks. In 90%, you have to just convert tan in terms of sine and cos, and you have to apply the identities. 1 minus sine square means cos square. Similarly, 1 minus cos square theta, which is equal to sine square theta, and so on. And this identity is a minus b, a plus b, a cube minus b cube, a cube plus b cube. Okay. So if you like this video, share with your friend and don't forget to subscribe. Thank you very much.